The next type of example can be categorized by or can be categorized into the problem of case number 3. What is it? Yx plus 2 minus 4yx is equal to 9x square. So 9x square, in place of n it is x square. I can term it as polynomial because it is nothing but the RHS wherein it is containing the polynomial. So case number 3 says that whatever 1 upon phi of e we will be writing, replace e by 1 plus delta, because the expansion should be done with the help of binomial theorem in powers of delta, because delta acts as delta is analogous to derivative in case of factorial polynomial. So I cannot proceed ahead with only this polynomial. I have to go with the factorial polynomial, conversion of this into the factorial polynomial, and then delta will be operated so as to get the simplification. So yx plus 2 minus 4yx is equal to 9x square. The given equation can be written in symbolic form as e square minus 4 into yx is equal to 9x square. The LHS is polynomial e square minus 4 equal to 0. E square is equal to 4. E is equal to plus minus 2. So complementary function is C1 into minus 2 to the power x plus C2 into 2 to the power x. Pi will be 1 upon e square minus 4 operated on 9x square. So before that, I have to replace e by 1 plus delta, right? Because complementary function can be evaluated or obtained with the help of e, because it is converted to the polynomial. But for the calculation or simplification of the particular integral, considering the RHS of the given differential equation, I will be writing down it in the form of delta, because delta can be operated on factorial polynomial. So in the meantime, in between, I have to convert this particular polynomial into the factorial polynomial also. So e is replaced by 1 plus delta. So 9 outside, 1 upon 1 plus delta whole square minus 4. The expansion of 1 plus delta whole square is 1 plus 2 delta plus delta square minus 4. So 1 minus 4 is minus 3. So क्या बनेगा यहाँ पर 1 upon minus 3 plus 2 delta plus delta square operated on x square. But I told you that we want it in the denominator 1 plus or 1 minus. So what is the lowest degree term? minus 3. So minus 3 will be taken common. क्या बचेगा 1 minus 2 delta plus delta square upon 3. This is how what we used to do, 1 plus phi of d. d को बाहर निकालते थे to get the lowest degree term outside है 1 plus या 1 minus is to be introduced, because when it is raised to power minus 1, binomial theorem or binomial expansion is applied. So minus 3 बाहर, 1 माइनस कलेक्टिवली इनके नीचे 3 से डिवाइड कर दोगे टू बी ऑपरेटेड ऑन x square. Now minus 3 and 9 will reduce as minus 3. 1 minus this particular term raised to power minus 1 is ready for binomial expansion. But when I will do this binomial expansion, this polynomial should not be a simple plain polynomial. It should be a factorial polynomial. So conversion of this polynomial to factorial polynomial कैसे होगा? टेक द कोएफिशिएंट्स, स्टैंडर्ड फॉर्म में इसको लिखेंगे तो 1 0 0, 0 से डिवाइड करो तो एज इट इज है, 1 से डिवाइड करो तो कोएफिशिएंट क्या बन रहा है 1 एंड 1. सो इट इज x टू द पावर 2 फैक्टोरियल प्लस x टू द पावर 1 फैक्टोरियल. देखो x स्क्वायर के लिए यू राइट डाउन x टू द पावर 2 फैक्टोरियल, इट इज x into x minus 1 which is x square minus x. But to cancel this minus x, I will add plus x. So this particular term is responsible for x to the power 2 factorial, and x is nothing but simply x to the power 1 factorial, right? So that is how this x square can be adjusted very easily. So directly without performing the synthetic division, if you try to, because x square अगर polynomial है तो factorial polynomial में भी उसका डिग्री कितना होने वाला है 2 होने वाला है. तो बाय डिफॉल्ट मैं उसको x टू द पावर 2 फैक्टोरियल लिख दूंगा. उसको सिंप्लीफाई करने के बाद कौन सा टर्म एडिशनल है उसको कैंसिल करो. Simplification of x into x minus 1 becomes x square minus x. तो माइनस एक्स तो नहीं है यहाँ पर, माइनस एक्स को कैंसिल करने के लिए प्लस एक्स करो, एक्स का मतलब क्या है, एक्स टू द पावर 1 फैक्टोरियल. सो आइदर यू डू इट बाय सिंथेटिक डिवीजन or directly, your answer is going to be same. So in this case, x to the power 2 या x square is written as x to the power 2 factorial plus x to the power 1 factorial. So when this denominator is written in the numerator, its power is raised to -1. Now the degree of the factorial polynomial is 2. So I will have to expand the term up to delta square, whose derivative exists, and rest all higher order terms will be 0. So it is 1 minus x. 1 minus x is 1 plus x square. That too I have to write this for this particular term because it will be giving you delta square. बाकी एक्सपेंशन सारे हायर ऑर्डर टर्म्स के लिए क्या हो जाएंगे, 0. सो सिंप्लीफाई, ओपन द ब्रैकेट, डेल्टा एक्स एज एनालॉगस टू द डेरिवेटिव x to the power 2 factorial का डेरिवेटिव रहेगा 2 into x to the power 1 factorial. X to the power 1 factorial is x. Delta of x is 1. After simplification, you are getting 1 plus 2 by 3 delta plus 7 by 9 delta square. See, this 2 by 3 delta plus delta square by 3 as it is रहेगा. Expansion of this क्या देगा, a plus b whole square. Concentrate on this term. A square plus 2ab plus b square. Middle term will give you cube. Last term will give you power 4. Ignore them. Only first term क्या देगा, 4 by 9 delta square. 4 by 9 delta square and 1 by 3 delta square को combine कर लिया. 2 by 3 delta as it is. 1 as it is. And 1 by 3 plus 4 by 9 is giving you 7 by 9. So I have got the simplified form of the expansion. Now term by term operate. 1 multiplied by this bracket is going to be x to the power 2 factorial plus x to the power 1 factorial. Delta operate करेंगे तो डेरिवेटिव होगा 2 into x to the power 1 factorial plus 1, right? And lastly square यानी बस इसका 2 to the power 2 into x to the power 1 का डेरिवेटिव सिर्फ क्या बचेगा, 2. And that is how now you write down it in the simplified form. Then x to the power 1 factorial can be written as x to the power 2 factorial can be written as x into x minus 1. Simplify it in the form of x, you get the particular integral. So this is how we try to simplify it with the help of the case number 3 when RHS is the polynomial. So major thing what you need to remember is replace e by 1 plus delta. Polynomial is to be converted to the factorial polynomial, use binomial expansion and simplify. So यहाँ पर आपने as it is लिख लिया सर, open the bracket, x to the power 1 is written as simply x, x to the power 2 factorial is written as x into x minus 1. You get the answer for that. Clear? So this was one of the example related to case number 3. The complete general solution is y of x is equal to c1 into minus 2 to the power x plus c2 into 2 to the power x minus 3 into so and so. Next question. Solve delta square minus 2 delta plus 1 multiplied by un is equal to n square plus 4. Un is multiplied means solution will be un is equal to cf plus pi. Now here, though delta is required for us in the particular integral, but initially to get the roots for the complementary function it has to be in the shift operator e. तो initially मुझे अभी delta को put करना पड़ेगा e minus 1. Simplify it, you get the polynomial, that is auxiliary equation. Solving that auxiliary equation you get the roots. How are the roots here? E is equal to 2 comma 2. 2 comma 2 means roots are real and equal. Whenever the roots are real and equal, we have the CF written in the form C1 plus C2n into 2 to the power n. Now this pi is 1 upon phi of e to be operated on this. तो यही original वाला term आएगा. So directly you can copy this rather than again putting e as 1 plus delta and trying to simplify. वही मिलेगा. उसमें से मुझे simplification क्या करना है, 1 plus 1 already है. So 1 plus क्या होगा, delta square minus 2 delta. Take this to the numerator. n square plus 4 को कैसे एडजस्ट करेंगे, do the synthetic division and accordingly write down. N square can be written as n to the power 2 factorial. Obviously वो तो रहेगा, but it is n square minus n. n square minus n, n कैंसिल करने के लिए प्लस n करोगे, प्लस 4 एज इट इज है. सो क्या होगा यहाँ पर, इट विल बी n to the power 2 factorial, n to the power 1 factorial plus 4, and that is how n square plus 4 can be written as. So it is n to the power 2 factorial plus n to the power 1 factorial plus 4. आई क्या बात समझ में? n square plus 4 में what I did, highest power was 2, so I wrote it into the form n to the power 2 factorial. But simplification for n to the power 2 factorial is n square minus n. माइनस एन इज एडिशनल, कैंसिल करने के लिए प्लस एन, तो मेरा सारा एडजस्ट हो गया बराबर. सो व्हाट आई एम गेटिंग इट एज n to the power 2 factorial plus n to the power 1 factorial plus 4. स्क्वायर है तो डेल्टा स्क्वायर का ही एक्सपेंशन होगा, उसके आगे नहीं होगा. एज व्हाट वी डिड इन द अर्लियर केस, एक्सपेंड इट अप्रोप्रिएटली, ऑपरेट टर्म बाय टर्म, बस इतना ही बचेगा. सिंप्लीफाई, n into n minus 1 will be substituted for n to the power 2 factorial, get the answer. The complete general solution is un is equal to cf plus pi. Similarly, the other kind of example, un plus 2 plus un plus 1 plus un is n square plus n plus 1. Convert it into the operator form, get the roots. Imaginary roots are alpha plus minus beta I, r to the power n into c1 cos n theta plus c2 sin n theta. R comes out to be 1, angle comes out to be 2 pi by 3. देख लीजिएगा from the calculator. I am getting complementary function as this. For particular integral, I want it in the form of delta. E should be replaced as 1 plus delta to be operated on n square plus n plus 1. Do the polynomial division, simplify it. From the denominator, take lowest degree term 3 outside, so that it will give you 1 plus some term or 1 minus. As the degree of the polynomial is 2, degree of factorial polynomial will also be 2. Expansion of this will be written only the powers as 2. 1 plus x to the power minus 1 is 1 minus x plus x square and so on. Operate term by term, simplify, you get the answer as 1 by 3 into n minus 1 plus 1 by 3. So that is how we try to simplify and get the answer. So this is how case number 3 can be easily simplified. Some more few examples are there. yn plus 2 plus 5yn plus 1 plus 6yn. What is the combination here? This is referring to case number 1. This is referring to case number 3. n can be simply written as n to the power 1 factorial. So case number 1 के लिए तो कोई ज्यादा दिक्कत नहीं जाएगी. Only expansion of this will be applicable for only one term, that is n to the power 1 factorial. Only first derivative will exist. Second derivative onwards, every term will be 0. Similarly, in this case also it is 2 to the power n plus 3n. 2 to the power n solvable by case number 1. 3n में से 3 बाहर, n can be written as simply n to the power 1 factorial, and then accordingly I have to simplify. But the problem can be replace e by 1 plus delta, operate it, simplify it, and get the answer. So the expected answer in this case is also like this, when only delta will be operated on n to the power 1. So in this way or manner we can